and welcome. My name is Emily Fortuna. I am a developer advocate at Temporal. And today I'm going to be talking about the Saga pattern, which is a design pattern frequently used in distributed systems and more specifically in microservices. I imagine there are a number of folks who are familiar with the Saga pattern and microservices and all that fun stuff. I'm starting from the basics so that I don't leave anyone behind, but we'll get to some hopefully interesting bits by the end of the talk. And I am talking about the Saga pattern by way of a trip planning or vacation planning analogy. So, just a quick outline of what I'll be talking about. First, what the heck are sagas? And what are the contexts in which sagas are useful? Then we'll dig into how you would build one, along with the very exciting live coding portion. And then a little more into how Saga pattern works and how we can make it easy for you. And then by the end of the talk, you will be an expert at Saga patterns. So, first up, what are sagas? Well, let's suppose that you are a white glove vacation planning service. You have a website and people come, they can put in where they want to go and what dates they want to travel, but they don't want to be bothered by like going to airlines and like figuring out what the cheapest flights are and then booking their hotels and so on. They just want to go somewhere and not worry about it. And so your service, hypothetical service, will then book these three things. They will book your flight for you, they'll book the hotel, and then they will book an activity, some excursion while you're there, maybe backpacking or a sightseeing tour or something. And now, it's not useful for your users if you only book, say, the flight, and maybe there's a very important conference happening in town and there are no hotels to be found. Then if they don't have anywhere to stay, then they might as well not book the flights. Similarly, if you have your hotel and your activities, but you can't get there, again, that's wasted money. So this is the crux of the Saga pattern. You have multiple steps that you want to execute all together in the case of planning a vacation. And if you can only do parts of it, then you should probably try and roll it back or undo as if you never did that in the first place. And so in our particular scenario, we're going to make this just a little bit more complicated. We are going to say that booking the hotel, there's an ordering to these tasks. Booking the hotel needs to happen after booking the flight, because maybe you want to take that flight number, put it in your hotel booking so that the hotel can pick you up at the airport. And then the activity needs to be booked after the hotel, because maybe there's some package deal that can happen with some hotels and you can get a discount on the activity. And so I made a little flow chart of what this process would look like. So at the top, we've got the successful path of booking your plane ticket and your hotel and your backpacking experience, for example. And then if one of those things can't happen, then we cancel the reservations of the preceding steps so that the user isn't out of money of a vacation that they can't completely enjoy. So let's dig into a little more formally what makes a saga. A saga is the sequence of steps where partial execution is undesirable. So with the vacation, you want the whole vacation, you need a place to stay and somewhere to get, or a way to get there. Otherwise, don't do it. And to make that happen, you need to clearly define forward progress. And that is done via retries in Or it also, you need to have clearly defined behavior for going backwards if, again, you can't book the whole thing. And these are called compensations. And so just to slightly modify my flowchart again, if, for example, the hotel is, or the airline service, if the website is unavailable, maybe it's a transient error, network error, you can retry trying to book that plane ticket once, a few more times, and then and hopefully proceed, because ultimately you do want to book this vacation for the user. But at some point you do have to cut your losses and say, it's never going to happen. And so if you have booked that plane ticket and you can't reach the hotel booking service, then cancel the plane ticket, and that's where your compensations come into play. So when are these useful? Because you might say, okay, this sounds just like regular logic. And so remember our scenario. Well, as I'm sure you are all familiar, code projects have this annoying habit of growing over time as you add functionality and your code gets more complex, and it grows in ways that you don't necessarily expect, but also it can be, as these things grow, testing a large body of code can take a long time. So maybe the development team or teams are getting frustrated because one team's releasing them all is becoming a bit of a headache, and testing is taking a long time, so they decide to embrace the world of microservices, and they divide their code up into the parts of that services website into groups. Now, the particular microservices we are going to focus on for this scenario is we have 3 independent microservices for these particular things that we are booking. And the reason these are independent services is because they're each booking out, or each connecting to independent third-party services that we, the vacation booking service, have no control over. And each of these things can fail independently. And so we want to be able to retry them independently. But now we have yet a different problem, because how do we make sure that how do we get these different services to talk to each other? How do we make sure that the ordering happens in the way that we want? And so that's where sagas come into play. Oh, and lastly, perhaps most importantly, how do we make sure that we, again, make sure all 3 services execute successfully, or we cancel and compensate properly so that it's as if none of them have executed. So, okay, cool. How do we build a saga? Just to remind you, sagas are this forward progress for the retries, or going backward progress, and going backward progress for compensations. So you might say, okay, for the retry part, I know some various Java libraries that allow me to do retries. Spring Retry has a very nice interface where you just annotate the specific functions that you want to retry, and you can specify your policy for how frequently you want to retry and so on. And then when it fails, you just annotate with recover. It's lovely. Resilience for J has a, now I will say, these 2 things are not apples to apples comparisons, so don't be like, resilience for J is so much more code, because Spring Retry, I'm only showing the interface definition. Resilience for J, because it uses decorators, I had to show the creation of or calling the service. So anyway, Resilience for J uses decorators. The code here is not that important. The point is that different libraries have different approaches. Failsafe uses, I was struggling to come up with a nice way to define this, but I call it composable objects, because you can take policies and kind of compose them and build up larger policies and compensation policies. Temporal uses annotations, and then it also uses a builder to specify its specific retry options. And so, okay, from that initial part, you're like, there's nothing new here. why are you trying to compete with Spring Retry? Stop trying to compete with Spring Retry. And Temporal adds additional layer of things. So let's talk about the retry libraries. So we have a caller, and we are calling a retryable function or service. And if that retryable function or service dies for whatever reason, after a certain period of time, the caller's like, hey, are you there? Try again. And then hopefully it's successful. However, what if that caller dies, or the service that is the caller dies? No one's asking you to retry. You're out of luck. And so now we have a problem. And this is where temporal can come in. And there are some other services. Well, let me back up. So fixed idea number one is, you might have the idea of snapshotting. So you say, okay, like every so often I'll like check all of my various services and like take a snapshot of their database and whatever. And if the one service goes down, I'll just kind of bring that up, back up and roll from there. There's a problem with this though. So, okay, and here's like taking a snapshot of the actual data. But the problem is, much like a literal snapshot, these people in this photo, we don't know where they were going. We don't know why they were going to do what they were going to do. We just know they were there at that point in time. And there's another problem with snapshotting, is if we have multiple services, different machines, what is now? How do we actually get a snapshot at the exact same time on two different computers and make sure that they are snapshotted? And so, unfortunately, you cannot just take a snapshot and roll back like Marty McFly and go back in time. So snapshotting is not a win here. So here comes this idea of event sourcing. The crux of event sourcing is like, okay, I've got service A, and I want to call service B. And so I will send a message when I'm calling it, and that message I will encapsulate as an event, a way of contacting service B. And then maybe service A writes to the database, and this is also relevant and important, and so we'll call that another event. And each of these events, we have a timestamp, and we add it to a log, and this is the crux of event sourcing, and this works. You can play the sequence of events, and you can kind of replay the history of your program's execution, or the service as a whole, not just an individual microservice. And so you can go back in time and go forward in time, or start from the current time and go forward in time. No one can tell the future. Great. So event sourcing is a way to go here. And then on top of this, the things that listen to the event log, and we take action on architectures that are built upon listening to these event streams, is what is called an event-driven architecture. And you may be familiar with, or may have attended a talk by the friends at Axonic, and their event-driven architecture, and they have fully embraced like defining your events and making this and building a allowing you to consume this and take stock of your program's execution history. Now, I will say that sometimes defining events can be tricky. And if all of what I've just said about events and the rest was like a little too hard to follow, then there's good news, because there's another option. Temporal uses event-driven architecture under the hood, but Temporal's philosophy is like, what if you didn't really have to worry about all of that, and we just took care of that for you, and you just coded as code as the developer that you are, and you wrote your business logic, and then we could, under the hood, save that event history. And if that caller went down in that scenario I talked about, then temporal, you could then restart the machine or start up another machine, and it would pick up exactly where you left off as if nothing had happened. So with that, let's jump to the code where we talk about how that works and what that looks like. Okay, so that is the README, and that's not what you want. All right, so I can make this bigger because I didn't expect the screen to be quite so large. It doesn't even look bigger. Does it look bigger? I feel like it's getting smaller. Oh, thank you. I'm trying to remember. Okay, I think it was 14. Oh, I thought this was... Oh, thank you. All right. All right. I think that's better. Great. Okay. Temporal divides your code up into two pieces. Thank you for the font assistance, everyone. We've got our workflow and our activities. So your workflow is your core business logic, and activities are all the pieces that can fail in your code. So things like network calls, things like writes to databases that you may or may not be able to connect to, these sorts of things. Your workflow is defined by just that annotation. And then in our activities interface, we define so, and you can define it's just a method that has been annotated as such. So in the workflow code itself, we have defined our retry policy. I'm currently every second for a maximum of 100 seconds with a back off of coefficient of 2. And I'm currently retrying infinitely. You can set a retry policy that is particular to an activity. And then, yeah, so here's our workflow code itself. It's pretty simple. Booking vacation, flight, hotel, excursion. And that's because I haven't added the compensations that I was talking about earlier yet. So in our activities, again, just a little code tour. Because I didn't want to actually be booking Lufthansa tickets every single time I decided to debug my program, I am unfortunately only doing a printf to simulate booking. Yeah, so we call book flight, and we set a flight confirmation number in this booking information object I have here that just stores like information like a credit card and flight number and so on. And then booked hotel, to enforce that order to make sure that the hotel happens after the flight, I check to make sure that there is a flight confirmation booking that is set. And similarly with excursion. And then the cancel hotel is similarly uncomplicated. They are just printfs showing that we are simulating canceling. Now, you may see that I have this idempotency key here. Well, let me introduce an error, and I'll talk about the idempotency key in a second. So let's throw unable to reach to complete booking. And we will comment this out. Okay, so okay, so we've got our we've started our worker, and then we have the workflow. So the workers are pulling work off of the workflow, which is here. And as you can see, we've got some stack traces because I inserted that failure. And I believe you can see that our attempts we are slowly creeping upward. Now, let's say you can look at my currently the way where the flight is. I have this runtime exception actually after the flight has been booked, supposedly. So if this function were to crash at this point and we retried, we don't actually want to book another flight because technically the flight has already been booked. And so that's where this idempotency key comes in. The definition of idempotency is a function, or a idempotent function is a function that can be run one, or the outcome is the same whether it's run 1 or 1,000,000 times. And so the idempotency key prevents us from booking the entire plane for this one single customer if I have to retry multiple times. To be clear, idempotency key doesn't mean that it's the same as if it had never run, because we do want to book at least once if the function runs. So I will take out my exception here, get back to a working thing. I'll kill this. And let us actually add in. So to be clear, I literally have no retry code added, but by setting a retry policy and adding the annotations, we get retries for free. Great. So let's add the compensation side of things. So there's a Saga library that I'm going to use, and it's very simple. All it does is it keeps track of the functions that we need to execute if in the event of failure. So I will do that. Complete with our Saga options builder. Great. And we want this to execute when, Sagas to run its compensations when one of these functions has thrown an error. So we're going to wrap this in a try catch. And I will keep it very generic. And then we'll call saga.compensate. Now currently, Saga has no functions that that is going to run in the event of when one of these functions or methods throws an error. So let's add some compensations. So you might say, hey, Emily, why are you adding this compensation up here instead of after book flight? And if we take a look at our activity code again, so let's say, again, that the flight has been booked, but before returning, we crashed right here. So then that means we jump down to this compensation logic. We call compensate, but their Saga doesn't have any compensations to run. So it's like, cool, we're good. But you have booked a flight. And so now your user is out of money, is out some money, and they're unhappy with you. So you need to put it before. That way, book flight can crash at any point throughout its code, and they'll be happy. This does mean that your cancel flight needs to take into account that maybe the flight actually hasn't been booked yet. So we need to kind of check for that. So compensation code, similarly for the others, same deal. Add cancel hotel and cancel excursion. And that's really all there is to it. We can run this. I'm going to I'm going to make this not retry forever, because then we will never see the compensation code run. So let's set a maximum attempts to, we'll just do 1, because I don't want to waste your time having you watch it retry. Get that going. And our worker. Not sure why we booked a flight twice. I will look into that. Oh, and we also haven't added our error, so of course it's not going to compensate. Let's add an error down here in the excursion thing. Oh, and cancel that out. Okay, so I'm going to see if this still attempts to run with 2. No. I believe that was, I'll have to look into why it was trying to run or book twice there. Maybe because I saved and hadn't killed the workflow. I'm gonna go with that. I will debug it later. But so since we're not having it reoccur right now, we've got our booking flight, booking hotel, booking excursion. We are, alas, unable to be a tourist, which is the worst error for your vacation service to return. And because of that, we cancel booking the excursion, cancel the hotel, and cancel the flight in the order that we want, because we want to do start from the most recently seen and go back in LIFO order, last in, first out. So that's all there is to it. We literally, Saga code is pretty simple by a matter of having a retry, our retries automatically set up for us, and putting our compensations in the set. So talk a little bit more about how this is possible with temporal. So to do that, we have to talk a little bit about microservices orchestration. And this is how these various services talk to one another. So there's 2 main ways to have services talk to one another. There's choreography and orchestration. Don't ask me why microservices orchestration has a type of orchestration. I don't make the rules. So to go back to our example, we've got these 3 services, and how do we make sure that the order it executes in the way that we want? Choreography, I like to think of in terms of ants. So you look at ants, and there is no like benevolent overlord that is telling them, the whole ant colony, where to go and when to go. They individually use pheromones to send chemical signals to one another about where they have found food, and then all of their friends can find the food too, and pretty soon you've got a little ant trail. And so the ants all have local knowledge. They don't have any sense of like how things are looking at the system as a whole. Similarly, with choreography in microservices, individual services are sending messages to the world, and their other fellow services can choose to respond to those messages or not. But again, there's no overarching service that is telling them what to do. They also have local knowledge of the world. Orchestration, on the other hand, is more like an air traffic controller. So you've got a single super service, if you will, that is directing the other services when to go and how to do so. That way we don't have multiple airlines, or multiple planes trying to take off at the same time, because that would be bad. So in the case of choreography, to make this a little more concrete, we've got our 3 services, and our plane service tells the world, hey, the plane has been booked. Proceed as you would like with that knowledge. And so it tells the world. The hotel booking decides to do something with that. They listen for that plane booked message. And then the excursion one doesn't do anything with that. Similarly, the hotel tells the world, hotel has been booked, and the excursion one does something with that. And similarly with the canceling, excursion says, hey, I canceled myself, and then everyone just does or does not do anything with that knowledge. But this can be, there are some drawbacks to choreography. If you look at the code for individual microservices, it's hard to understand what is the behavior of the system as a whole, because you only know what each service is listening to for an event. You have to look at the code bases in each microservice to understand. You don't have this clear 1, 2, 3 ordering that we had in the temporal code we saw. So spoiler alert, temporal does not use choreography. It's also can be difficult to debug. So say the excursion service dies, and the hotel service dies, and the excursion service says, hey, I canceled myself. Who's paying attention to know that no one has responded to this message? No one. And also just tracking the sequence of events, or tracing the sequence of events and debugging can be difficult as well. So generally, only for the most simple of cases, and even in this case, it can be difficult, is it recommended to use choreography. But it can be simpler to implement. Orchestration, on the other hand, you've got your message broker, your super service, if you will, that tells the other services, passes messages to them and tells them what to do. So a message broker tells each of these 3 services to book in the order that the message broker determines, and similarly cancel. As you may have guessed, between these 2 options, temporal uses orchestration. The downside of orchestration is you have a single point of failure, because if that message broker falls over, what happens? The good news is, because temporal is perfectly horizontally scalable, and we've recorded your the program execution as a whole, you can, if that message broker dies, you can start it up on another machine, and you've got your whole program execution history. You can continue running again as if that message broker never died. So falling over or single point of failure is not quite as bad as you might have worried. So I talked a lot about retries and compensations, but temporal offers a lot of other things. One that's particularly useful for sagas is timers. So you can have long-running timers, and if that the service running that timer falls over, temporal will start it back up again, and it can take note of what was the last time that a message event was seen and now, and it can determine whether or not it needs to fire the next timer event. So maybe in this vacation booking service, once a year it recurs. We book a new vacation. That's totally possible. A timer that long is totally possible with temporal, because you can fall over it, and it's okay. We are open source with a hosted option. The QR code on your left is the a link to our GitHub repo, and on the right is a link to our cloud repo. And yes, I will. So yeah, there's no difference between the two. The difference is that you can pay Temporal to host that server-side components, and we will deal with making sure that that is always up and running, and you don't have to make sure that you move that stuff over to a new machine should that the high-level code fall over. So just to recap, what are sagas? They are long-running transactions, this long-running sequence of steps that we have clear forward and backward progress defined because we want to always ultimately go forward as much as possible. And why use sagas? Well, when we got microservices and we are calling out to a third-party things such as like calling out to an airline or a hotel that with the database content we don't control, or if just having multiple database on each service, and we talked about that snapshotting problem. And again, partial execution is undesirable. That's key for when is the time to pull a saga out. Talked about specifics on how to build one with a little detour into event sourcing and event-driven architectures. Saw some code. You helped me with my font. And then lastly, how Temporal works is it's an orchestration engine that guarantees forward execution. So congratulations, you are now a Saga expert. Three handy links. We've got how to get started with the Java SDK, and also the Slack. I didn't make a QR code for that one. Apologies. And then the bottom QR code is a link to the repo with the all the code that I was using today. If you want to dig into it and play with it yourself. So thank you very much, everyone. I will gladly take questions. We also have a booth here. So if you have more questions or want to like try out stuff, we are pretty near the down escalator. I'll turn it over. Questions, anyone? Yes. Yes. Right. So yeah, I kind of skipped over that a little bit. So Temporal actually they don't have these activities. You could call them microservices, but they're a little bit different. You can have them at any granularity. You could make them finer grained than you might with your typical microservice code. And so your workflow, this is your workflow right here. That's it. And you saw that when I was getting it to run, I had two separate windows. I'll kill it. I had the worker that I started and the initiate planning. This starts the workflow engine, if you will, under the hood, but it's the workflow. And then that's not what I wanted. And then this starts up the workers that then execute that workflow code for you. Does that answer your question? Try again. Ask you one more time. Yes. No. So this is temporal, maybe what the question is, maybe behind the scenes, temporal is doing the orchestration for you. You only need to call code as you would normally. Fitz, you seem like you have something you want to say. No, I wasn't calling you out. I just looked like you were.
I think the idea, sort of, you still need the pool of workers somewhere that is able to run the workflow code. And then what the activities do is, it could be microservice-like, or they could just be a plain function. But the workers, there has to be some worker somewhere that exists, and that worker code is just pretty simple. It's this function. Wherever you deploy anything. Most people have them in like a Kubernetes cluster and just have it auto-populate with nodes.
Yeah, so this is the actual worker code. I didn't show it because it creates the clients to talk to the workflow, and then it says what are the, it's under the scenes using RPC to talk so that the workers know what these activity methods are. So we register them, and then we call start. But that's really all there is to it. Thanks. Yes.
What is the back end for these worker thread areas? So I think you said if we have a lot of millions and millions and millions of bookings, we have to kind of doing a pooling or something like that. And then we have some kind of queuing mechanism or something like that just contains the messages that are coming in initially. Is there any basic backend supporting that?
That I don't know. Fitz, do you know? I want to say that is something that you, the developer. So there's kind of two pieces. There's that the workflow, and then like your workers that are running. And so like I think that is something that you, the developer, would determine for your use case.
I think that's fair. I think the worker factory here lets you define things like how many threads there are, how often it polls. You can run as many of these processes as you think are necessary. Each one can have as many threads as it needs. And so you, as the application developer, as Emily was saying, are going to define that load profile for yourself. On the other side, on the temporal side, we have just a task queue that is sitting there waiting for polling requests to hand out work.
And that queue is kind of implemented in a specific way, so having a full-fledged database under the hood, or?
Yep.
Okay. Thanks.
Anyone else? Yes. Oh, the compensation? Yeah. Yeah. So, well, first of all, let's look up at our interface again. So you see I've annotated them with activity methods because they're activities as well. And so by virtue of that, they have also your retry policy. Now, and you can set specific retry policies per method if you prefer. But the short version is like you would retry to the best you can, and then if you cannot do, if those break, I would probably you could also then like log that you were unable to complete the, like maybe in the activity, either in the activity in the cancellation here, I might, if I just did it once, if it fails, I would have this in some sort of try catch and then log it so that then my sysadmin can have that flagged and look into it deeper. But yeah, you'd retry, and then if it's permanently down, if the airline has gone out of business because and they have taken your money, then I guess you need to get on the phone with customer support. Compensations? Well, so not if I wrap them here. Oh, you're saying yes, if it would keep retrying, which is so I guess that argues to trying to do it once and logging, and I suppose you could. Yeah, that is a problem with the Saga Design Pattern, I would say. Anyone else? Thanks for being such a great audience.